In this video tutorial, you will learn how to configure data exchange using GOOSE messages and data transmission via MMS reports. Further, the process of setting in configurator software will be shown. The setting can be made through the Smart Monitor software in the similar way. Before starting to work with the configuration, we recommend that you watch the video tutorial opening and saving of configuration file. After successful opening of configuration file, move to System Parameters section. In this section, in the Ethernet Protocols tab, select IEC 61850.81 and make sure that the protocol enabled box is checked. The transmission and reception of GOOSE messages is enabled. Next, start configuring the incoming GOOSE messages. Open the incoming GOOSE section. In the Open tab, there is a list of GOOSE messages and settings area of the selected GOOSE message. If there is a CID file of GOOSE publishing IED, use import and add the incoming GOOSE messages automatically. For this, press import. Select the CID file and in the open window for every GOOSE message select the signals that have to be received. Then press add. All necessary settings will be applied automatically, and signals will automatically assign to the virtual input modules. If there is no CID file of GOOSE publishing IED, the setting must be made manually. Use the buttons in the upper part of the list to create and delete GOOSE messages. Add new incoming GOOSE message. Select the existing GOOSE message to configure it. Specify such parameters as multicast MAC address, application ID, control block, dataset, GOOSE ID, GOOSE configuration version, VLAN enable and VLAN ID, as in the project or according to the parameters of the GOOSE message existing in the network. These parameters can be viewed using any traffic analyzer. By default, in case of connection loss or poor quality of signals, or a test GOOSE message, the signals of incoming GOOSE messages will take the previously received values. If preset signal values have to be selected, use the default value from drop-down list. Next, press the default value button. In the appeared column, specify value for every signal. If the box is checked, the value will be specified as true. If unchecked, false. Check the fixed encoding flag box if the publisher applies fixed length encoding while forming a GOOSE message. This means that every symbol of sent data is coded by a definite quantity of bits. Find more information about it in the IEC 61850 standard, section 8-1. If publisher applies unfixed length encoding, leave the box unchecked. To receive binary or analog data over GOOSE protocol, assign the incoming signals to the modules of binary or analog inputs, respectively. To do this, in the setting area of selected GOOSE message, add the quantity of data that corresponds to the quantity in the incoming GOOSE messages. The window shows the maximum quantity of data that can be added. After adding, they will become available for assigning to the vacant virtual input. For easier identification, specify GOOSE message signal names and virtual input names. In the similar way, for GOOSE messages with analog data, we add float type signals and give them names. The upper part of this area contains available virtual modules, the lower matrix for assignment of incoming GOOSE messages data to the virtual inputs. Note that for reception of the signals with bool, SPS, bitstring 2 data types, the virtual binary input modules are used. For the signals with float type data, virtual analog input modules. Herewith, bitstring 2 data type requires 2 virtual binary inputs at once. To determine type of the module in the Modules section, select one with the relevant name. Module type is specified in the library block parameter. If there are no vacant virtual input modules available, it is possible to add new ones. Bool, SPS and bitstring 2 data type signals assigned to the virtual binary input modules can also be used in the logic, configured to the IED binary output, to registering, recording of waveforms and etc. Check out the video tutorial binary inputs, outputs, logical signals and indication to know how to do it. Float data type signals assigned to the modules of virtual analog inputs can be used in the measuring elements and calculated values. Check out the video tutorial analog inputs and measured values to know how to configure them. The settings are checked through testing, changing signals of the GOOSE message we need to receive. To exclude the action of IED to the external circuits, we recommend switching the IED in GOOSE Publisher to the test mode. Find more information on switching the IED to the test mode in the video tutorial checking of IED modules and functions in testing mode. For checking, load the changed configuration to the IED as described in the video tutorial updating and recovering of configuration and firmware. If the changes were introduced through Smart Monitor software, save them into the IED according to the video tutorial changing the settings. Comparison of setting groups. Next, proceed to the Smart Monitor section service menu. Network Diagnostics. In the Open tab, select 61850 GOOSE IN from the drop-down list. Let's demonstrate the testing of the reception on the third GOOSE message. GOOSE message is received correctly if the counter of received packets increases, while the counters for other devices, decoding errors, sequence number errors or time to live errors do not change. If these counters change, proceed as follows. If for other devices counter changes, check for errors such parameters as application ID, GOOSE ID, and GOOSE configuration version. If decoding errors counter changes, check for errors the list of received signals. If time to live errors and sequence number errors counters change, it means that GOOSE messages are not coming or coming with long delay. Then check the fact of each signal reception. To check the reception of bool, SPS and bitstring 2 type signals, in the IED tree open current values. Discrete signals. Digital inputs. In the open window, find the signals of the GOOSE message being checked and in sequence change their values in the GOOSE Publisher. The values of the checked signals should change according to the changes made to them in the GOOSE Publisher. To check the reception of float-type signals, in the IED tree open current values analog inputs or calculated measurements, depending on how you configured the incoming data. In the open window, find the signals of the GOOSE message being checked and in sequence change their values in the GOOSE Publisher. The values of the checked signals should change according to the changes made to them in the GOOSE Publisher. This ends up the configuration of incoming GOOSE messages. Next, configure outgoing GOOSE message. Open the outgoing GOOSE section. In the Open tab, there is a list of GOOSE messages published by the IED in Settings area of the selected GOOSE message. Use the buttons in the upper part of the list to create and delete GOOSE messages. Add new outgoing GOOSE message. To configure newly added GOOSE message, select it from the list. For dataset parameter of configured GOOSE message, select the dataset, which contains the list of signals for sending. View the contents of the selected set, add or delete signals, and create new or delete the existing dataset in the section with the same name. The signal list, which will be transmitted using GOOSE or MMS, is created in this section. In the Open tab, there is a list of datasets, setting area for the selected set parameters, area of signals available for adding and area of signals added for transmission. Use the buttons in the upper part of the list to create and delete datasets. Add a new dataset. In the displayed menu, select the set type, which will determine the list of signals to be added. For example, select the data type, digital set. To configure the added dataset, select it from the list. Dataset name can be changed at the user's discretion. Selected dataset type is shown in the set type parameter. The structure type parameter defines if there will be some additional information, such as signal generation timestamp and signal quality, transmitted together with the selected signal value. If the value structure type is selected, only the signal value will be transmitted. If the value, quality structure type is selected, the signal value and its quality will be transmitted as separate data. If the value, quality, timestamp structure type is selected, the signal value, its quality, and the time of its last change will be transmitted as separate data. If the data object structure type is selected, value, quality and time will be transmitted as one data object. The structure type parameter value is defined by the project or by the functionality of the signal receiver. It is recommended to transmit signals as data object. Then drag the required signals from the area of signals available for adding to the area of signals selected for transmission. Note that the quantity of signals transmitted by one GOOSE message has limits that are specified in the IED design documentation. When adding analog signals or calculated values to dataset, configure the deadband for every transmitted signal. The deadband determines what value the signal has to be changed to, for its renewed value to be transmitted via the digital communication protocols. Configure this parameter in the analog inputs or formulas section, depending on the signals group. For example, to configure the deadband for analog signal, move to the analog inputs section. Select the required signal, and in the ASU parameters field set deadband as a percentage from the basic value, or in absolute values. When one value is specified, the other will change automatically. Configure deadband for calculated value in the same way in the formulas section. In the Open tab, find and select the required value. In the parameters field, set deadband the same way as in the analog inputs tab. It is also necessary to specify the maximum value parameter to set the deadband in relative units. This completes the configuration of dataset. Now in the settings of outgoing GOOSE message, select the created dataset. Note that transmission of one dataset simultaneously over GOOSE and MMS protocols is not allowed. For example, to transmit a dataset via MMS protocol, which is already being transmitted via GOOSE, one will need to create one more identical dataset. To ease the GOOSE messages setting process, we recommend specifying GOOSE class. Herewith, values of multicast MAC address, application identifier, normal period of GOOSE transmission and minimal period of GOOSE transmission, quantity of messages with a minimal period of transmission will be preset according to the selected class and standard IEC 61850 recommendations. When hovering the cursor over a GOOSE parameter, the popping up window shows the permissible value ranges. You can change the values of these parameters within the range. If GOOSE class is not selected, value setting is not limited by class range. Multicast MAC address has to be unique for your network. If MAC address is not specified in the project, set it according to the IEC 61850 standard. Next, specify application identifier that also has to be unique for your network. Application identifier can be set in hexadecimal or decimal format. When setting in one format, the other will change its value automatically. If this value is absent from the project, then it is recommended to set it as equal to the value of the 6th octet of the group MAC address. For example, for GOOSE message with this group MAC address, set application identifier as equal to 55. Such approach to application identifier assigning allows excluding the coincidence with other devices, because there cannot be two devices with identical MAC addresses in one network. In the control block parameter, set a unique name using Latin letters, numbers, or symbols. Next, using Latin letters, numbers, or symbols as well, set GOOSE identifier that has to be unique for your network. Then set GOOSE configuration version. This parameter is useful to track the quantity of GOOSE message settings adjustments. Next, set normal period of GOOSE transmission and minimal period of GOOSE transmission as per project or according to the importance and urgency of messages delivery. If one of the GOOSE classes was selected previously, then hovering the cursor over the period field calls up the information on the permissible range of set values. When the next box is checked, the send period is doubled until it reaches the standard sending period. The box can be unchecked, then doubling the sending period occurs for the number of messages specified below, after which the sending period is immediately taken equal to standard. If it is needed to publish GOOSE message with a definite virtual network marker, check the VLAN enable box, specify VLAN ID and VLAN priority. Next, specify network interface from which the specified GOOSE message will be published. If subscriber device supports only messages with fixed encoding, then check the fixed encoding flag box. If subscriber supports unfixed message encoding, then do not check the box. For checking of GOOSE message setting, load the changed configuration to the IED as described in the video tutorial updating and recovering of configuration and firmware. If the changes were introduced through Smart Monitor software, save them into the IED according to the video tutorial changing the settings. Comparison of setting groups. To exclude the action of IED to the external circuits, we recommend switching the IED to the test mode. Find more information on that in the video tutorial checking of IED modules and functions in testing mode. The outgoing GOOSE message settings can be checked in two ways. The first way, check using the subscriber device, receiving GOOSE messages. The subscriber device must be in the same network with the publisher IED, configured to receive the checked GOOSE message, support the reception of test messages and show values of signals. In Smart Monitor software, move to the section Tests, Matrix Inputs Emulation, and enable the emulation mode. Next, find the signals of the GOOSE message being checked and in sequence change their values. As a result, the values of checked signals in the subscriber device should change according to the changes made to them in the publisher IED. The second way, test using a network analyzer, such as open source software Wireshark, that has to be installed on the PC. The test is conducted as when using subscriber device. Only the changes will be displayed in the window of Network Analyzer. This ends up the configuration of outgoing GOOSE messages. Configure the signals transmission via MMS reports in the Report Blocks section. Configuration tab is divided to the field with MMS reports list and parameters of the selected MMS report. Use the buttons in the upper part of the list to create and delete MMS report. Add new MMS report. It is recommended to set the report name using Latin letters, numbers, or symbols. Next, from the drop-down list, select the report type, based on the type of the data to be sent and the need for buffering of these data. The main difference between the buffered and unbuffered reports is that when using the first one, the generated data will be delivered to the client even if there is no connection between server and client at the moment of reporting, for example, due to short-term communication channels break. All generated data accumulates in the device memory and will be transmitted when the communication between devices will be restored. For this case, there is a restriction of memory available for report storage. When the memory is full, the new data will replace the old. That's why we recommend to select unbuffered reports for transmission of analog signals. The drop-down list of the dataset parameter contains only the datasets that correspond to the selected report type. For example, when selecting buffered or unbuffered binary type, only binary datasets will display in the drop-down list of the dataset parameter. For the MMS report, select the unbuffered discrete type and a relevant dataset. Note that transmission of the same data set over GOOSE and MMS protocols is not allowed. For example, to transmit a data set via MMS protocol, which is already being transmitted via GOOSE, one will need to create one more identical dataset. If periodic sending of MMS reports is needed, in that the period of sending reports, set the time interval of periodic sending and check the box to enable periodic sending. Next, specify data buffering time. This parameter defines the time after signal value change, during which the changes of all signals will accumulate, and by the end of this time, the report will be sent. At repeated change of signals already changed during this time, all changed signals will be sent and the waiting countdown will restart. Next, configure reports block configuration version. This parameter is useful to track the quantity of MMS report settings adjustments. One MMS report can be taken only by one MMS client at a time. For sending of reports for all clients, it is necessary to have the relevant quantity of report control blocks. Specify the required quantity of configurable report copies for this purpose. Add report ID for easier identification in the data model. In the fields, check the boxes with the required information that will be included in the report. In the modes, select the reasons for their transmission. Note that the majority of current MMS clients have an option to specify the MMS report with such parameters as the period of sending reports, reports block identifier, fields, and modes. If this is your case, then there is no need to set these parameters. To check MMS report setting, load the changed configuration to the IED as described in the video tutorial Updating and Recovering of Configuration and Firmware. If the changes were introduced through Smart Monitor software, save them into the IED according to the video tutorial Changing the Settings. Comparison of setting groups. To exclude the action of IED to the external circuits, we recommend switching the IED to the test mode. Find more information on that in the video tutorial Checking of IED modules and functions in testing mode. The correctness of MMS report settings can be verified, for example, using MMS client of such open source program as IED Explorer that has to be installed on PC. Device with MMS client should be in the same network with server IED and should be subscribed to the configured MMS report. In the Smart Monitor software, move to the section Tests. Matrix inputs emulation and enable the emulation mode. Next, find the signals of the MMS report being checked and in sequence change their values. As a result, the values of checked signals in the MMS client should change according to the changes made to them in the publisher IED. This ends up the configuration of MMS reports. After configuration editing, save it in the File menu or by pressing the Save button on the toolbar. This ends up the video tutorial. We hope it proved itself useful to you. Thank you for your attention.